a global warning sign. The Swiss Alps function like an early warning system for Earth's climate, akin to canaries in a coal mine. What happens here today signals what will unfold elsewhere, often with greater consequences. Scientists monitor these mountains closely because changes appear earlier and more dramatically at mid-latitudes than near the poles or equator. The 2 degrees Celsius temperature rise that shrank Swiss glaciers by 60% since 1850 mirrors the same warming now affecting global systems, just on different timelines. Globally, the patterns are strikingly consistent. The Alps lost 50% of glacier ice in 150 years, while the Andes lost the same percentage in just 50 years, 3 times faster due to their tropical location. Arctic sea ice decline follows a similar trajectory, with summer ice cover reduced by 40% since 1980. These delays reflect how climate impacts propagate through Earth systems at varying speeds, with the Alps often experiencing changes first. Hydrological disruptions provide a clear example of this ripple effect. The Alps now release meltwater earlier each summer, with peak flows shifting 6 weeks since 1980. This same phenomenon hits the Himalayas with larger consequences, as their 1.5 billion dependents face more extreme river fluctuations. NASA satellite data confirms that glacial-fed rivers worldwide now peak 2 to 3 weeks earlier on average than in 1990. The per-river's erratic flows foreshadow similar challenges for the Indus and Ganges basins. Food systems also reveal interconnected vulnerabilities. Switzerland's shrinking alpine pastures reduced milk yields by 8%, a moderate impact compared to the 30% production drops hitting Andean quinoa farms as their glaciers disappear. The same warming that stressed Swiss vineyards is pushing South African wine regions toward unsuitability. These shifts illustrate how agricultural belts are moving poleward at roughly 25 kilometers per decade. Infrastructure impacts scale globally as well. Swiss engineers spend €150 million annually stabilizing railways as permafrost thaws, while Alaska faces $5 billion in transportation repairs for the same reason. Italian cities ration Rhone-sourced water during shortages, just as Mexico City now does with its shrinking glacial watersheds. The physics remain identical. Ice melts, ground destabilizes, and water supplies fluctuate. Economic ripples follow similar mechanisms. A single Swiss ski resort snowmaking costs increased 30% last decade, while Japan's ski industry now spends 50% more on artificial snow. Lyon's higher water treatment costs mirror Johannesburg's struggles with sediment from melting Drakensberg glaciers. These parallel responses highlight how climate change acts as a universal economic tax, paid differently but everywhere. Biodiversity shifts further under the global parallels. Alpine species have moved uphill 11 meters annually since 1990, while the Rockies see a similar climb of 15 meters per year. Butterflies disappearing from Swiss meadows reappear in Scandinavia, their ranges shifting poleward at 6 kilometers yearly. These movements demonstrate climate's role as a great redistributor of life. Even cultural losses echo internationally. Swiss villages hold funerals for glaciers, just as Iceland did for Okjekul in 2019. From Bolivia to Bhutan, landscapes central to identities are disappearing, turning localized mourning into a shared global experience of grief over environmental loss. Feedback loops amplify these changes. The Alps' darker exposed rock absorbs more heat, just as Greenland's ice sheet reflectivity has dropped 15% since 2000. Switzerland's thawing permafrost releases methane, while Siberian permafrost emits 20 times more. These reinforcing mechanisms operate identically, just at different scales worldwide. The timing of impacts reveals deeper truths. For every 1 degree Celsius of warming, alpine ecosystems shift noticeably within 15 years, temperate zones respond within 30 years, and tropical systems manifest changes after 50 years. This staggered response explains why Switzerland experiences today what Mumbai or Miami will face tomorrow. The Alps transformation previews the compressed timelines and intensified disruptions awaiting other regions. Ultimately, the Alps don't just reflect global change, they actively contribute to it. Melting glaciers raise sea levels, exposed rock alters regional albedo, and economic adaptations reconfigure supply chains. What began as local environmental change now affects planetary systems through countless feedback loops. The Alps' fate intertwines with Earth's future, making their loss a global concern. The Swiss Alps reveal the stark reality of climate change and the urgency for action. While 40% of glacier loss is now inevitable, the extent of future loss hinges on today's choices. Cities are adapting water systems, and farmers are planting drought-resistant crops, proof that solutions exist. Each degree of avoided warming preserves critical ice reserves. The Alps stand as a vivid metaphor, a delicate balance between irreversible loss and the hope of preservation. Their disappearing ice and shifting ecosystems remind us that the future isn't predetermined. It's shaped by the actions we take now.